Image classification is fundamental in the field of machine learning and computer vision. At its core, this technique revolves around training a computer to identify the content of an image by referencing predefined labels. Training with labeled data involves teaching the model using examples where the correct answers or labels are already known. Think of image classification as the computer consulting a vast guidebook filled with more than 1,000 labeled images, all to make an accurate prediction about a new unfamiliar picture. Now let's dive into an example. We present our system with a picture of a tiger. Using image classification, the computer processes it and declares it is seeing a tiger. And not just that, it also telling us how confident it is in its prediction. In this case, it is 63%. That confidence score helps us gauge how well the computer thinks it recognized the image, a handy metric when we are dealing with thousands of possible categories. First off, we grab a handy tool from our library called pipeline. It's a function designed to make things run smoothly. Next, we use our pipeline function to specify that we are doing image classification. For this, we pick a model named vet-patch16224 to help us out. Then we show our program a picture of a tiger. We do this by giving it the picture's link. The program will then peek at the picture and guess what it is. The program comes back saying it thinks it's a tiger, plus it is 63% sure of its answer. So we know the picture's name and how confident our tool is about that name. If you have a picture on your computer and it's not online, you can still use it. First, we turn the picture into a special link using URL create object URL. This gives us a special link that our program can read. After we get this link, we pass it to our classifier and it takes a look at the image and gives its guess. Sometimes just one answer isn't enough. Imagine you have shown a picture and you are curious, what else could this be? For moments like that, we can ask our classifier to give more top guesses. And it is as simple as passing an object to our classifier with a special key called top K. This time, not only did our program recognize it is as a tiger, it also thought it could resemble a tiger cat or even a lion. Okay, now let's go to the implementation. So we go to our web page, we go to computer vision category, and we click on image classification. Then I'll go back to Visual Studio Code and I will open the file. As usual, the first thing we do in the file is that we create the script tag. We create this tag with type module because we want to use the import method inside this script tag. Then we import the pipeline from the URL. I'll show you once more where to get this URL from. So if you go to Transformers Hugging Face, if you go to Transformers.js in particular, installation, you can see that we have the link here. Okay, let's go back to our code. The next step is that we will attach the pipeline to the window object because variables created within a script tag of type module are scoped locally. So to make the pipeline function available globally, I attach it to a window object. Okay, let's go down now to the initialize model, and here in the initialize model I will declare the classifier. I will call the pipeline function. I will tell it is image classification, and I will pass the name of the model. Of course, the initialize model is async because this use await, and in order to use await, the method shall be async. And in the await, it means that it will take some time to execute, and we will wait until it to come back. Of course, this initialization may take around a minute sometimes, depending on your internet connection, but it will download the
model and it will be cached, so subsequent calls are faster. So the first time you load the model, maybe you load the page, maybe you need to wait for a minute to make sure that the model has been downloaded. Okay, then let's go to the handler classify image. The first step, we get the text input value, which is a URL of an image. As you can see here, this is a URL of an image. After that, we just fire the classifier. We pass to it the URL and we wait for the result. It's a wait because it takes some time. Once we have the result, we actually convert it to a string and output it into the output area. Let's go now to the web page and let's try classifying this image, which is an image of a tiger. Let me classify. As you can see, it thinks that it is a tiger with a confidence of 63%. Okay, so the next one, we will, instead of using a URL on the internet, we have a local file that we need to classify. So to do so, I come back to Visual Studio Code. I have this classify image local, which is the JavaScript handler of this button. Here, I will, for the first thing, obtain the file input control, and from the file input control, I get the selected file, which is files of 0 because I have only one file. Now, after that, I just make sure the file is there, otherwise I will alert and return. Then the very important step, we use the URL object to create an object URL of this file. It returns a URL that I can use as normal URLs. Now I will fire the classifier, giving it the URL exactly the same as we did with the online URL, and then we output the result after converting it to a string. Okay, let's go to our application, choose file. Of course, I have these images in the images folder as we saw in the previous session. So I will select this tiger. I will classify, and as you can see, it is a tiger 63% confident. Okay, so it is 63% sure. So up to 100, it seems that it also thinks that it could be something else. So to do that, we have in this subtask that we will pass the same URL, but we will ask it to give us the top 3 predictions. So go back to the code. I will first get the URL from the text input and store it here. And then I will fire the classifier as usual. The only difference is that here we specify a JavaScript object which contains a key called top k, and I set it to 3, meaning return me the top 3 predictions you have. That will be returned to a result, and I will convert to string and output to the output area. Now if I go to the page, if I classify, okay, you can see it's telling us that it is a tiger and it's sure 0.63%. But it could be a tiger cat and it's sure 0.36, and it could be a lion, but no, it is not thinking that it could be a lion. It's very low. So it thinks 63% that it is a tiger, or 36% that it is a tiger